In this video, we'll be working a problem that requires the use of the sum and difference identities for cosine. If you've not already done so, press pause to copy these identities into your notes. When you're ready to continue, press play. The example that we'll be working is find the exact value of the expression cosine of 7 pi over 12. Now, because this word exact is in here, that means we're going to need to use our special angles. And I'm going to write those over here on the side. We have a 30-degree angle, which we know is pi over 6. We have a 45-degree angle, which we know is pi over 4. And we have a 60-degree angle, which we know is pi over 3. Now, since my problem is in twelfths, I'm going to change these so they're all in twelfths so I can look at how I need to combine them to get 7 pi over 12. In order to get a 12 in this denominator, I'll multiply top and bottom by 2. So this is 2 pi over 12. Multiply top and bottom here by 3. So this is 3 pi over 12. And multiply top and bottom here by 4. So this is 4 pi over 12. Now it's easier to see that to get 7 pi over 12, I'll want to combine 3 pi over 12 and 4 pi over 12. So I'll rewrite this as the cosine of 3 pi over 12 plus 4 pi over 12. Now I know from my identity, the first one here, that the cosine of A plus B is cosine A cosine B minus sine A sine B. So I can use that identity to write this as cosine 3 pi over 12 times cosine 4 pi over 12 minus, notice that when it's the sum of the two angles, you have a subtraction sign between the two products. Minus sine 3 pi over 12 times sine 4 pi over 12. Now I'm going to draw my reference angles for these two. 3 pi over 12 we said was 45 degrees, so that's in quadrant 1. This is 3 pi over 12, and I have 1 root 2. And then 4 pi over 12 we said was 60 degrees. So I'll use this reference triangle. This is 60 degrees, which is 4 pi over 12. 60 degrees across from that is a root 3, and then a 1 across from the 30, and then 2 on the hypotenuse. Alright, so to get cosine of 3 pi over 12, I'm going to use this reference triangle, and I want the adjacent over hypotenuse, so 1 over root 2 times, and then for 4 pi over 12, I'll use this reference triangle. Cosine is adjacent over hypotenuse, so 1/2. Subtract. Again, 3 pi over 12, I'm over here on this reference triangle. For the sine, I want opposite over hypotenuse. That's 1 over root 2 times. And then for the sine of 4 pi over 12, I need this reference triangle. Sine is opposite over hypotenuse, so root 3 over 2. I'm going to rationalize the fractions with radicals in the denominator, so I'll multiply top and bottom here by root 2, and multiply top and bottom here by root 2. So this factor becomes root 2 over 2 times 1/2. Subtract, and this one becomes root 2 over 2 times root 3 over 2. Now I'm going to multiply. Root 2 times 1 is root 2. 2 times 2 is 4. Subtract. And then root 2 times root 3 is root 6. 2 times 2 is 4. Now these have a common denominator, so I can combine them. And it'll be root 2 subtract root 6 over 4.